this. So I think my explanation is weird. So just please tell me what you think, right? So today's topic is feed of ocean plants, and you know what feed is? What's abbreviation of what word? Who know? Yes, very good. Uh, last lecture, Professor Zhang tell us about what is feed is, but nobody tell me.
Nobody knows of it. Should explain.
Feed is front-end engineering and design. And today's lecture content is these three features of ocean plants and design procedure of ocean plants and three project activities. And before I start the lecture, let's watch some funny YouTube videos. Today's topic is ocean plant, so you can watch about selfie of ocean plants. Isn't it scary that you think work on the offshore platform right here? I think I'm core, so if I work there, I kind of move like an ice. So, does anybody want work in here? I'm not. So, as you see, many shipbuilding companies also build ocean plants, and shipbuilding and ocean plant is quite similar but a little bit different, like you learned in last class by Professor Chang. And first, ship can move around, but ocean plant is in fixed location, and unique plant that ship has a regular route, so we can make many similar ships, but ocean plant is in fixed location, and every ocean plant has their own environment. So we need their unique design for each ocean plant, so it's unique. And safety is important in ocean plant because it's not on land, it's in offshore. So safety is critical and independent. This building is connected by pipe or electrical lines with other buildings, but ocean plants they need their own power and their own things like this, so it's independent. And as you watching the video, the operating condition is varies so much, and you can work in the low wave and sunny days, and after that 2 days you can work in harsh condition. So it's varying operating condition and concurrent design, engineering, fabrication. So, same thing in last slide. So, repeated design is not allowed, and it needs unique design and safety critical and brand condition. So we need risk-based design. Risk is not just about the environmental risk. We must think about the schedule risk or cost. So similar to R&D. And Wikipedia says engineering design process is like this. And first problem definition and feasibility study, conceptual design, make a concept, and bid and detailed design and production plan. And the front end engineering design is makes from your concept more developed design, and you can make it fit to detailed design after contract. So in subsea system, you make unique concept and make a fit, and contract is between fit and detailed design. And after contract, you make design more detailed and procurement, 조달 in Korean. And project management service and construction, operation, and last decommission. It's about not a poor plant or ship, it's about equipment. It's similar. First design and procurement, manufacturing, and sending to engineering company, and engineering company receives the equipment, and after the construction, shipbuilding companies add to their operation. Ship design inspire. This is design spiral of shipbuilding, and you may think about the four things: and naval architecture and structure and propulsion and machinery and auxiliary systems, electrical systems, four things, and we must think about from the concept. We must think about four things from the concept, and in functional design, we consider again and detail design and consider again and make more precise, your design more detailed, and make a less design that you do. And this is more complicated one for this design style. So in ocean plant industry, the monies come from the oil and gas. So oil and gas company is the client. So the company client, and company gives the work to the contractors, engineering companies, and engineering companies find the suppliers for the equipment and constructors, and last, after the construction, the shipbuilding company receives the final ocean plant. But nowadays, the one company can do four things, like from the feed and engineering, procurement, or construction to the commission, the installation. So, like you buy a car, you don't find the engineer for a car and going to receive the design and going to the car factory and make my car like this. You will just give your money to the car dealer, and car dealer gives you a car and you put the key on it and turn it and drive. So if a company client gives just money and give contract limit, and just a contractor doing it all, it called turnkey contract. So front-end loading, there's 3 phases. Yeah. First, business planning phase, and think define the business opportunity that, and this is doing by the oil company client, and oil company and client found the engineering contractors, and they doing the design more detailed and precise. And at end of the feed, they make a contract and doing detailed one. You saw similar graph last class. So when you design a subsea system, front-ended design is more important and give more influence than construction and commissioning. As you see, the front phase of the project is more effect to the value identification. Just execution or construction gives a small change to the final value, and you similar graph. Value can only be safeguarded or eroded during the execution. So first, DG means design gate. Feed is doing in design gate 3, and before the feed, you need a concept. And you must identify what you need, what they need, and assess, make some concept and choose your concept, select your concept, and make a basis for design. And in design gate 3, you use basis of design and doing your feed and make a contract. Any other questions? Okay, and